Hi everyone! In this video, we'll explain what mobile interruption testing is, which types of interruption testing exist, and show the most common bugs that a QA engineer may encounter during interruption testing. Thank you for joining this video, and let's get started. This video is a part of the Udemy course Manual Software Testing Interview Q&A for QA. For more information, check the description below the video. Interruption testing is a type of software testing that focuses on evaluating how a system or software application responds when it is interrupted by various external factors or events. Nowadays, mobile devices have a wide range of different functions that can interrupt the application. Therefore, interruption testing is the first candidate to be performed on mobile devices alongside general types of testing, and it plays a key role in assessing the quality of mobile applications. This type of testing is particularly important for mobile app developers and quality assurance teams to ensure that the app can handle interruptions gracefully without crashing, losing data, or compromising its functionality. Interruptions can come in various forms. Let's take a look at several of them. The first one is phone calls. Phone call interruption testing is a specific type of interruption testing that focuses on how a software application or mobile device responds when a phone call is received or initiated while the application is in use. Several questions that the QA engineer tried to answer during the call interruption testing include: does the application pause or minimize its operation? Does it provide the user with options to answer the call or ignore it? The application should preserve its current state and user data so that the user can easily return to their previous task after the call ends. If any errors occur during or after the call interruption, the application should handle them gracefully and provide informative error messages to the user. The next type of interruption is SMS or notifications. SMS or notification testing focuses on evaluating how a software application, especially mobile apps, responds when it receives SMS messages or other notifications while the application is in use. Several questions that the QA engineer tried to answer during the SMS or notifications interruption testing are: how the application displays incoming SMS messages or notifications while the app is running, whether the application provides options for the user to respond or dismiss incoming SMS or notifications, how the application reacts to different types of notifications, for example, push notifications, in-app notifications, system-level alerts. The next type of interruption is device hardware interruption testing. Device hardware interruptions testing involves simulating various hardware events and interruptions that can occur on a mobile device, assessing how these events affect the device's operation and the applications running on it. The common scenarios and aspects that test in device hardware interruption testing include: 1. Pressing dedicated buttons on the device such as power, home, lock, multitask, volume, or any other depending on the using device. Mobile users frequently interact with their devices through physical buttons. It's essential to ensure that when these buttons are pressed during app usage, the application responds as expected without crashing or misbehaving. The next scenario is 2. Screen capture and screenshot interruptions. During this interruption, tester examines how the application reacts when users capture screenshots or record the screen. This event can briefly interrupt the application's user interface, and test ensures that the app continues to function properly afterward. On the screen, you can see the button to press for making screenshot on iOS device. First is to press home and lock buttons on the device simultaneously. The second is to press volume up and lock buttons on the device simultaneously. The next scenario of hardware interruptions testing is multitasking the app switching. During this interruption, tester evaluates how the application responds when users switch between multiple applications, push it to the background, or launch other apps. The application should save its state and recover seamlessly when brought back to the foreground and back to the background again. The next scenario of hardware interruptions testing is device rotation. During this interruption, tester assesses how the app reacts to changes in device orientation, such as when the user rotates their smartphone from portrait to landscape mode or vice versa. The next scenario of hardware interruptions testing is sensor-based interruptions. Sensor-based interruptions in mobile devices refer to situations where the device's sensors, such as accelerometers, gyroscopes, or ambient light sensors, trigger events or actions that may affect the operation of the device or the applications running on it. During this testing, QA engineer tests how the application responds to sensor-based interruptions, such as changes in proximity sensor readings or ambient light sensor values. These sensors can impact screen behavior and touch sensitivity. The next scenario is USB connectivity and disconnect. During this testing, QA engineer evaluates the application's behavior when the device is connected or disconnected from a computer or other external devices. USB connectivity and disconnect testing is vital for mobile application developers and testers to confirm that application can seamlessly interact with a variety of USB devices and configurations, ensuring reliable data transfer, a positive user experience, and device compatibility. The last scenario of hardware interruptions testing is headphone insertion removal. During this testing, QA engineer tests how the application responds when headphones are plugged in or removed from the device. This may involve audio routing changes and should not cause application crashes or audio issues. The primary objective of device hardware interruption testing is to ensure that the device and applications can adapt to a variety of hardware-related events and interruptions without causing crashes, data loss, or a poor user experience. By conducting thorough testing in these scenarios, developers and testers can enhance the reliability, stability, and overall usability of both the device and its applications. The next type of interruption is network interruptions. Network interruptions testing involves evaluating how applications and devices respond to disruptions in network connectivity. Unlike web testing, where interruptions to the internet connections are rare, mobile devices experience disruptions such as network interruptions or connectivity issues more frequently. Therefore, network interruptions testing plays a crucial role in ensuring the quality of mobile applications. Usually, during device network interruptions testing, QA engineer verifies, simulating scenarios like switching between Wi-Fi and mobile data, encountering poor network coverage, or experiencing temporary network outages to assess how the application behaves under such conditions. The next type of interruption is battery issues. Battery issues testing for mobile devices is testing the app's response to low battery warnings and power-saving modes, which may cause the app to run with limited resources. Usually, during battery issues testing, a QA engineer verifies how the application behaves when the device's battery is in low or critical state, how the application behaves when the device turns off because of low battery, and then launch the device and back to the application. Let's take a look at the most common bugs that a QA engineer may encounter during interruption testing. Example 1. Application crash. Crash occurs when a software application unexpectedly and abruptly terminates, leading to the application closing without the user's intention or control. When an application crashes, it typically ceases to function, and users may see an error message or experience the application closing abruptly, potentially leading to data loss and user frustration. Imagine that a QA engineer should perform network interruptions testing. For that reason, the tester installs the application on the device, for example, the Play Store application on the Android device. The next step is to launch the application. The Play Store application is launched and the home screen appears. In order to make the network interruption, the tester goes to the navigation panel of the device and switches off the internet connection and then back to the application. Theoretically, the expected behavior in such a case is the offline notification message that should appear on the application screen indicating that the user is currently offline. However, instead of it, the QA engineer sees the next pop-up. The Play Store application isn't responding. And the option is to close the app, wait, and send the feedback. It's a crash of the application that is caused by the network interruption. Thorough network interruption testing can prevent this issue and improve the reliability and usability of the mobile application. Let's take a look at the second example. Example 2. Stuck of the application. A stuck bug in mobile applications refers to a situation where the application becomes unresponsive or stuck and fails to respond to user input. Imagine the QA should perform out of it. The QA engineer sees the next pop-up. The Play Store application isn't responding. And the option is to close the app, wait, and send the feedback. It's a crash of the application that is caused by the network interruption. Thorough network interruption testing can prevent this issue and improve the reliability and usability of the mobile application. Let's take a look at the second example. Example 2. Stuck of the application. A stuck bug in mobile applications refers to a situation where the application becomes unresponsive or stuck and fails to respond to user input. Imagine the QA should perform device hardware interruption testing. For this reason, they install the application on the device, for example the LinkedIn application on an Android device. Then the tester launches it and starts testing, in particular being on LinkedIn homepage. The QA press on the Home button on the mobile device. After pressing the Home button, the LinkedIn application goes to the background and the home page of the device opens. The next step is for the QA engineer to press the multitask button on the device, choose the LinkedIn application from the multitask menu, and return to it on the foreground. Theoretically, the expected result is the user should be able to navigate through the application without difficulties. For example, switch between application tabs, My Network, Notification, Jobs, create a post, scroll the screen, perform a search, and others. However, the application becomes unresponsive or stuck and fails to respond to user input. This issue can manifest as the app freezing, not updating the user interface, or failing to complete a task. A stuck application can be frustrating and irritating for users. It can lead to a poor user experience, and users are more likely to uninstall or leave negative reviews for such apps. Ensuring smooth and responsive applications by device hardware interruptions testing is vital for retaining and satisfying users. Let's take a look at the third example. Example 3. Application doesn't pause during interruption. Imagine a QA engineer should perform the call interruption testing. For this reason, they install the application on the device, for example, the Spotify application on an Android device. After the Spotify application was installed, the tester opens it on the device 1, then chooses desired radio and starts the playback, adjusting the volume. Then, using another mobile device 2, the QA engineer makes a call to the device 1, where the Spotify application is running. Theoretically, the expected behavior is: in response to the call interruption, the application should pause or mute on the device 1 to allow the user who is calling to be heard. However, after receiving the call, the playback on the Spotify application doesn't stop. Therefore, it's a bug. The Spotify application doesn't pause during the call interruption. In order to listen to the call, the user needs to navigate back to the Spotify application, pause the playback on the radio first, and then return to the call. This behavior of the application is inconvenient and may lead users to cease using the application and leave negative reviews. Mobile interruption testing can prevent this issue and ensure the quality of mobile application. That's all from our side. If there are topics that you would like to see, write a comment or question to the lecture. We hope to see you in the next video.